Today's lecture is about the problem of design. So the obvious place to begin, isn't it, is with things that are clearly not designed. This is just a plain ordinary stone. The laws of physics, left on their own, will produce something like that. They can also produce something like this, which looks superficially like a boot, but the resemblance is purely accidental. It means absolutely nothing. Nor does the resemblance of this to a fish mean anything, nor the resemblance of that to a duck's head. This is slightly more interesting, but it's still purely fortuitous. It looks like an egg, and inside is a little dummy embryo. But again, it's pure luck. That's just produced by physics alone. That's also true of these rather beautiful-looking crystals. But this is rather more interesting, because crystals are what you get when atoms, all of the same kind, are allowed to stack up together in the way that they, quote, want to do. It's a different kind of crystal, a desert rose, almost looks as though it might have been made by a jeweler. But all these objects are fortuitous. None of them is designed. All the stones belong in a category that I'm going to call simple. The same is true of clouds and stars. Nobody designed them. They came to be the way they are by the simple consequences of the unaided laws of physics. They're examples of the way things just happen to be. Now we're ready to look at some objects that really are designed. This microscope, nobody could possibly mistake that for an object that just happens to be the way it is. Everything about it has design written all over it. It has a long tube to look down, a lens this end, another lens that end, a mirror to reflect light up through the tube, knobs to change the focus, other knobs to move the slide from side to side and back and forth. Even the knobs themselves are roughened to make them easier to grip. A designed object. The same is true of this calculating machine. The same is true of this watch. There are some slightly more difficult cases. These flint arrowheads, there's not much doubt that they're designed. They are shaped in a way that you wouldn't normally expect a stone on the beach to be shaped. This one's a bit more doubtful. Experts tell us, archaeologists tell us, that that is a designed object, that some primitive people did indeed shape that for a purpose, and I'm prepared to believe them. But that's a slightly more difficult case. Never mind about them. There are plenty of objects which are absolutely obviously designed. What do they all have in common, these designed objects? They are all good for some purpose, and they couldn't have come to be the way they are by luck. The microscope is obviously very good at its purpose of greatly magnifying objects, and most certainly it couldn't have come about by luck. If you take a lot of atoms and shake them up at random, then you may get a crystal, but you will not in a billion years get a microscope. This is a gazunder, so-called because it goes under, and it has a more humble purpose than the microscope, but it works very well in its purpose. It's clearly designed. Once we realize what its purpose is, which is to hold water, we can come up with a crude measure of how good it is. We can say the cost of the pot is the amount of clay that goes into it, and the benefit of it is the amount of water that it holds. And so its efficiency is the ratio of the weight of water that it holds to the weight of clay that goes into making it. We compare it with this pot, which is not made by man, but is a natural stone. It also would hold water, but it wouldn't hold very much water for the amount of stone that goes into it. Its efficiency ratio is not very high, and indeed it's not a designed object. It is a simple object which just happened to be. So we've divided these objects into those that are designed and those that I'm calling simple. But now I want to introduce a large and very important category of objects that are certainly not simple, and I shall argue that they are not designed. But they look overwhelmingly and compellingly as though they were designed. And I'm going to call them designoid objects. Designoid objects look designed, but they actually got their designed look from a very different process, which we'll come on to later. You may find it hard at this stage to believe that designoid objects are not designed, but just wait. So let's have our first designoid object. Thank you. Now this is Andrew, isn't it? And what's the snake called?
Squeeze.
Squeeze. The snake's called Squeeze. It's a boa constrictor, and it is a magnificent example of a designoid object. It looks as though it's been beautifully designed for a purpose, and one of those purposes is swallowing prey which look very much too large for it to swallow. And one of the ways in which it achieves this is by the head. All right. The bones of the head, the bones of the skull, are capable of detaching, coming apart, under the skin, of course, so that the head swells to a huge size relative to what it starts. And there's a great gaping maw, which is capable then of swallowing very much larger prey than you'd think. The skin here is a beautiful mottled colour, which you could imagine would be very, very highly camouflaged in a forest. The snake has lost its legs. Losing legs is a very common thing among reptiles. There are many lines of evolution of reptiles which have lost their legs. What the boa constrictor is best at is throttling its prey. And I think that both Andrew and Squeeze deserve a round of applause. Thank you very much. Just looking at the outside of Squeeze gives us no real idea at all of what an extraordinarily complicated structure he and all other living things is. A living thing like Squeeze is not just more complicated than the microscope. It is billions of times more complicated than the microscope. Let's come back to pots. We've seen a designed pot, and we've seen a simple accidental pot. Now here's a designoid pot. This is a pitcher plant. Here you see the individual pitchers. There's an enlargement. They're filled with water, and they're traps for insects. Insects fall into the trap and drown. This is how a pitcher begins. This is the next stage in development. It begins as a leaf. You see the hole just beginning to form. This is a young pitcher. And then we're going to see, there's the full pitcher, there's a fly climbing up it, there's a slippery area at the top, the fly's down into the water, it's now going to drown, and in due course, its products will be digested by the plant. Here is a live pitcher plant, here is one of its pitchers, you can see the little lid over it, there's the slip zone there, and inside is the water. It appears to be a well-designed object, a well-designed pot. If we were to do our cost-benefit ratio, our measure of the amount of water that it holds over the weight of the plant material itself, we'd find that it was a very efficient pot indeed. But we'd also find that if we looked inside, cut sections of it, it would have a very complicated structure.